Hello, everyone. I'm Gaole He. The authors of this paper come from Web Information System Lab of TU Delft. Today, I will show you our work on diverse knowledge elicitation using a game with a purpose. In real-world applications, AI systems need plural types of common-sense knowledge. For example, to answer this question, we need the knowledge that restaurant is not a holy place, while synagogue is. While existing common sense knowledge base store relational facts about the world, the discriminative knowledge and negative knowledge, such as restaurant is not a holy place, is typically absent from existing large-scale knowledge base. In this paper, the collected knowledge tuples fall into generative and discriminative category, meanwhile contains positive and negative signs. The generative knowledge describes the real-world fact in the format of subject, predicate, object. The sign here indicates whether the attribute holds or not in real world. Another type of knowledge is discriminative knowledge, which describes whether the attribute can discriminate two concepts. The sign then indicates whether the two concepts can be discriminated with such attributes. For example, we can see that fish and octopus can be distinguished with has a fins because fish always has a fin, while octopus not. But meanwhile, we know that both human and lion are mammals, so we can discriminate human and lion with the attribute is a mammal. Common sense knowledge may have renewed usage in the context of artificial intelligence, such as improving neurosymbolic AI and debugging machine learning models. In these usages, we need plural types of knowledge, such as negative, discriminative, and tacit knowledge, which are typically absent from existing large-scale knowledge base. With the recent trends in human computation, there are new opportunities to collect such knowledge at scale. Game with a purpose is an effective and enjoyable approach to collect common sense knowledge from human players. However, little is currently understood about the types of knowledge that can be gathered using existing knowledge elicitation methods. Moreover, these methods fall short of meeting the evolving requirements of downstream AI tasks. Addressing the research gap, we developed a novel game with a purpose, Find It Out, to elicit different types of knowledge from human players through easily configurable game mechanics. First, I will show you our approach, Find It Out, about the game procedure and how we collect knowledge from this game. In the game, we first provide a detailed tutorial about the game, including rules and design features to all participants. Find It Out is a two-player competitive game. The objective of the game for each player is to guess the opponent's ID card. Each player has an ID card which is at the top middle part of his interface. In this case, junk is Gaole's ID card. To guess the opponent's ID card, each turn one player asks questions based on provided relational templates. In this slide, Gaole plays the role of asker. In our game, we provide 8 relation-based templates, which can be found in the bottom part of the slide. All relations in Find It Out are selected from ConceptNet. With the selected template, Gaole creates a question by inputting free text. Then we have the question, is your card an object? After Gaole submits the question, the opponent, Agatha, will receive the question. As the slides show, Agatha will respond to the question, is your card an object, according to her own ID card, garage. We have 3 options here, yes, no, maybe, which corresponds to the positive, negative, and uncertain answers. If the replier, here, Agatha, feels that the question is not clear to answer, she can respond with unclear. Then the asker needs to rephrase his question. After opponent sends back the answer, asker can discard some candidate concepts with flipping the card. Like here, Gaole flip garage and genre with the answer no to question, is your card an object? Then he can choose enter or guess If he chooses an turn, Gaole and Agatha will switch their rules and take another turn. Now it's Agatha's turn to ask a question and reduce candidates in the game boards. After a few rounds, the asker can make a guess to end the game. If he correctly guesses the opponent's side card, he wins this game. Otherwise, he will lose. In this slide, Gaole wins the game and have an interaction history from his side. If the opponent lies during the game, he can report it with the report mistake function. To guarantee the quality of collecting consensus knowledge, we have following feature designs. First, we provide varying game difficulty through the number and types of cards in game board. In our experience, the boards which contain abstract concepts like fun, happiness becomes more challenging compared to game boards composed of concrete daily items. To ensure both players have equal chance to win, if the opponent makes a correct guess, this player can still make a guess and have the equal chance to win and get a bonus from our study. Just as we observed in panel study, some players may cheat by misleading opponents with responding wrong answer. After the game, each player can find any such cheating behaviors with reporting mistakes. To help players understand each concept, we provide definitions about each concept from WordNet when they hang their mouse on each card. We also employ table words to ensure that the questions asked by the players are not too simple and allow to extract useful knowledge. We use this slide to illustrate the knowledge collection from player behaviors. Given the question, is your card an object? And the answer is no. The asker flips the card genre means that genre is an object. Meanwhile, the card garage is reserved unflipped. It indicates garage is not an object, which can be saved as positive and negative generative knowledge. With card flipped and unflipped in the same turn, we can obtain discriminative knowledge. As genre and television are both flipped in this turn, they can't be distinguished with relational properties. Is an object. It's the same for the garage and attic, which remained unflipped in this turn. With the same behaviors in this turn, we construct negative discriminative knowledge. But when we consider the genre, which is flipped this turn, and garage, which keeps unflipped, we can draw positive discriminative knowledge, as genre and garage can be discriminated with relational properties is an object. Then let's move to the experimental evaluation about the collected knowledge. In our experiments, we evaluate the knowledge collection process and the quality of collected knowledge. All players are crowd workers held from prolific platform. The game boards are generated from two benchmarks of different tasks, namely discriminative attributes and common sense question answering. For the qualitative assessments, the authors followed an iterative coding process and discussed for the standard of each dimensions to reach a consensus. In experiments, we have 255 games played for DA datasets, which collected around 75,000 knowledge tuples, while 242 games played for common sense question answering dataset, which collected around 86,000 knowledge tuples. On average, easy games lasted around 6 minutes, and players spent around 4 turns for each easy game. Similarly, difficult games last 6.5 minutes, and players spend around 6 turns for each difficult game. On average, the throughput is 13.9 tuples per minute per game for finding out, which is 10 times the existing method verbosity. We also observe that the difficult games correspond to a high utility for the discriminative attribute task, while easy games correspond to a high utility for the common sense question answering datasets. For more details about the knowledge collection evaluation, please refer to our paper. Based on our findings from the player experience questionnaire, the main functionalities of finding out were well understood and appreciated by players. On average, players rated the functional consequence, which indicates the immediate experience as a direct result of game design choice, with about 1 on a scale of -3 to 3. This highly rated functional consequence also translated into highly rated psychosocial consequence, with an average rating per dimension always above 0. This shows that finding out was enjoyed by players, aroused their curiosity by prompting them to think of topics that they probably didn't think of. To assess the quality of collecting knowledge tuples, we defined 7 dimensions which fall into the category of correctness and diversity. Zooming into each dimension, we find that most generative tuples collected are meaningful, correct, and unbiased. And we also find the collected knowledge tuples have a relatively highly tacit and specific knowledge, while also a small ratio of typical knowledge. These findings confirm that finding out allow for externalizing tacit knowledge that is typically not found in existing knowledge base. To assess the usefulness of knowledge collected for discriminative attribute datasets, we calculated the coverage of reference triples to create the game boards. In our experiment, 28.8% of triples are covered. Meanwhile, all potential concept pairs of the discriminative attributes are covered, which goes beyond the scope of original dataset. For the common sense question answering dataset, we manually annotated the relevance and usefulness for each question. For each question, we retrieve top 5 relevant knowledge tuples generated with semantic similarity. The results show that more than half of choice in each question can find relevant knowledge tuples, and around 10% choice can find useful knowledge, which can directly confirm the answer or discard a distraction term. In conclusion, mainly, this work have following contribution. First, we designed a novel configurable game with a purpose, find it out, which can collect plural common sense knowledge at scale. Secondly, we provide a structured set of dimensions for knowledge characterization. Thirdly, we conduct an empirical study about the performance of find it out based on crowd workers. Furthermore, we conduct qualitative study of collecting knowledge tuples and a quantitative study of the efficiency of knowledge collection process. In the future, we will also consider, first, improve the quality of collecting knowledge with post-processing, such as redundancy, and secondly, the generation of game boards largely affects the collecting knowledge. We will also explore how to generate more meaningful game boards based on efficiency, quality, and player experience. And thirdly, we may explore to use the plural large tuples collected from find it out on downstream tasks. Thanks for your time and listening. For more details about our game Find It Out, you can refer to our paper. Meanwhile, our demo and code is available online.